moving on to question 7. This one might be a little bit hard, but you know, it is what it is. Now we have a car and a trailer moving upwards up a slope, and then we have their mass, we have this angle right here, we have the driving force by the engine, we have the car is accelerating, and then there are some resistance forces, and we have to show that the resistance is R equals 60. So given all of these numbers, what I would do is F equals ma. Now we know that m is 1200 plus 600, and then times 0.75, and then this is also equal to all the forces summed together, right? So we have to find out all the forces. First, this is 3000 newtons here, right? And then we also have 2 R newtons, and then R newtons of resistance, and lastly we're missing the gravitational force, the component here. So this is alpha, and then this would be 1200 G sine alpha, and then this would be 600 G sine alpha. I don't know if this is clear enough. So what we are doing is, since the gravitational force is pulling downwards, but the other components are like, there's an angle here, so we have to create, how do we say it? We have to dissect this gravity vector into 2 different vectors. That is like this in this axis, and we have to use this. Now, since it is moving upwards, we have to denote this direction as the positive direction, so 3000, and then other components are all minus, so this thing here, yeah. And the sine alpha is, this is 112, this is 10, and then I don't know what these other numbers are. Just plug it into a calculator and you'll get R is 60 newtons. Okay, find the tension in the tow bar. This is kind of messy, but I guess we can do it. I guess we must have a tension like this, and these 2 forces must be equal. Otherwise, the cars would be moving in different directions, in different speeds. So how do we model this tension and this tension? So the tension in the trailer, let's write it like this: trailer T. We'll have to model all the forces, so T minus 600 G sine alpha, and then minus the resistance, would equal to 600 times 7.5. This is from F equals ma. If you only account for forces acting on the trailer. I hope that is clear enough. And then for the car, it would be T. Wait, sorry. No. Since T is moving here, right? That means it's a negative force. We have to use 3000 first, and then minus this, and then minus 2R, which is 120, and then minus T would equal to 1200 times 0.75. Then just solve the simultaneous equation, and you'll get T equals 1000 newtons. Okay, sorry, I'm not doing like I'm not calculating all of this, but like you know, the rest should be easy, I hope. And then part C. When the car and trailer are moving at the speed of 12 meters per second, the tow bar breaks. Given that it remains unchanged, use a model to find the further distance moved by the trailer before it comes to rest. Okay. So basically, it's a Sulfat equation, I think. We can find the acceleration first. So F equals ma would equal to 600 times a, and it will equal to all the forces summed together. So it should be it should be minus 60, which is resistance, and then minus 600 g sine alpha. And then if we solve this, we would get a is negative 11 over 12, which is around 0.9166. But we should use this to calculate. And then in the Sulfat equation, we have what? The distance equals. Wait, no, which one should we use here? We should use, which one is this? Phi squared equals u squared plus 2as. I think it's like this. So we know that phi squared must be 0, right? Because we're trying to find the furthest distance moved by the trailer. So imagine it like this. The car has a bit of motion upwards, and the furthest it can arrive at, like at this point, it must be phi equals 0. If otherwise, if phi is larger than 0, it can move a little bit upwards. If phi is less than 0, that means it's going downwards. So phi equals 0 must be like the furthest point. So u squared is, what was it, 12 squared, and then plus 2 times this, and then this, and then if we solve for this, s would be equal to 78.5 meters. I don't know if I explained that well, but to be honest, there's nothing much to say about these kind of questions. You just have to model all the forces. It's kind of a classic question. So for part A, you have to use Newton's second law. For part B, you have to isolate two systems, okay? Part A, you will have to consider the whole system, and then part B, you have to isolate two systems, and then you have to solve them simultaneously. This is the kind of questions that will appear. And then for part C, it's kind of they have all sorts of questions, so I can't really give advices.